Yes, my name is Eileen Malik. I've been teaching for a long time. First of all, let's see, I know some of you are using mobile devices, and if you're using mobile devices, not sure if you can access the range using the login and the code. But if not, I mean, all this material is readily available. Autopsy is a free software meant for law enforcement. And I kind of stumbled on it by accident. And actually, really, things don't really happen accidentally for a reason. Things are always awesome. So I'm going to talk a little bit about my journey that got me into Autopsy and how we came to where we are. I did a slide presentation, obviously, you know, using Zoom and doing PowerPoint and flipping back and forth would have been a nightmare. So what I did is I made a PDF copy. Everyone has PDF copies, as well as I'm placing it inside the little cyber range room just so I can keep track of one window. That's, you know, how nervous I get about things. In these slide presentations, I try to make it look like a book. In terms of, as well as seeing the slide, you'll see little yellow Post-it notes. And if you're an educator, which most of us, by judging by the poll, looking at the poll that everyone, hopefully everyone did, most of us are educators. So if there's a little tidbit for computer science or cybersecurity educators, I put it in a little yellow Post-it note. Other than that, some of the new information is available on the slide. Okay, so, and it scrolls. I'm sorry, it scrolls. Okay, so first of all, I'd like to note that my background is not in computer forensics. I am not a law enforcement person. I'm actually a high school computer science educator, STEM educator, and I've been doing it for, this may be my 20th year. So, you know, COVID's like, oh no, it's only 19. No, this will be my 20th year teaching computer science education. And then during COVID, someone, I think it was a Facebook page for cybersecurity educators, they said, hey, you've got 1 week to do this autopsy training, which is normally $500. I said, oh, okay. So I like challenging myself. Usually, I know like some people are very stressed right now, especially us as educators, because there's so much uncertainty going on. For me, I like to take on challenges. You know, I like to do things that aren't easy. So I said, hey, I'm going to do this autopsy training and see how I do. And it really kind of kicked me in the tuchus a bit because it was pretty difficult, because the assumption was that you had basic knowledge in law enforcement and digital forensics, which I did not. So it was very interesting going through the training and understanding it from a law enforcement personnel perspective, but it really had a bunch of gems for computer science education. So obviously, you know, computer forensics, it's a really hot career right now. Because there's tons of, the big thing that I want to tell people is, they're like, what's the big difference between cybersecurity and computer forensics? Well, computer forensics could be thought of more of as if you have any sort of hardware, that gets confiscated. It could be a mobile device, it could be an SD card, it could be a computer, it could be a desktop, it could be a gaming system. The computer forensic or the digital forensic experts are the ones that go in there to determine, hey, you know, is there any sort of information that will help us in any sort of investigation? So, and that's a picture of me with, I actually had a cybersecurity crew. The really good looking one, and that's right behind me in the rear, that's my son, he plays football. And well, not this year. Anyway, so I did the training, and what we learned about Autopsy, it has a mascot. It's called Renzik the Autopsy Dog, and it's an open source computer forensic platform. What does open source mean? Obviously, it's free. you can make changes to it. You have access to something known as like the kernel, where you can make little tweaks to it. You can customize it for your needs. And it's endorsed by the National White Collar Crime Center. I found this out when I heard about Autopsy software. I'm very suspicious of stuff. So when I first found out about Autopsy, I said, hey, is this real? You know, am I being punked? Am I going to have my personal information stolen from me? So I contacted my really good friend that's in the Virginia State Police. He's First Sergeant Robert Keaton. I have a picture of him at the end of my slide. And I said, is this real? He goes, oh yeah, it's been around for a little bit. We're looking into it. It's endorsed by the National White Collar Crime Center. So he goes, yeah, tell me, why don't you just go in there and tell me what you think? And I said, oh, that's great, that's great. So I did it, and I did the training, and it was a little more difficult than I imagined, but I really liked what it covered. So what does Autopsy do? Okay, so here's the formal definition. All my images were Creative Commons images. I love doing Creative Commons images because I'm not stealing them from anywhere. And when I reference them, you know, they're free and available. But what does Autopsy do? It analyzes hard drives, smartphones, flash drives, SD cards. It's a graphical user interface. It's a Windows-based graphical user. I know that Virginia Cyber Range had Autopsy available through Linux, and it was command line driven. And so they said, why don't you use that? And so when I went back to First Sergeant Robert Keaton, I said, hey, do you guys use the Windows version, or do you do like the Linux command line version? He goes, oh, we do the Windows version. I said, okay, well, I need to do the Windows version because that's what law enforcement does, thank goodness, because Windows is easier, like for a visual person like myself. So it displays the results from forensic search of data from a variety of digital sources, just to see if there's information that will help in an investigation. So what does that really mean in a nutshell? Like, what does this mean for our students? And let's see, before I get back to that one, for our students, basically what it does is it finds everything on computer devices, whether or not you've deleted it, reformatted the drive, if you've changed the file extension to try to hide it, in some cases, even after it's been damaged. Perfect example was after I used Autopsy, I told my students, okay, I've got this flash drive, okay? So you're gonna put some stuff on here, better not be inappropriate because I'm gonna find it, but put some stuff on here and make it so I can't find it and give it back to me, and I bet I can find it. So they took it, and this was not the original one. I'll tell you what happened to the original one, but they put some stuff on there and they gave it back to me, and I said, okay, so you had this picture, and this picture on there. And they're like, oh, how'd you find out? We deleted it. I said, well, I used Autopsy, and Autopsy found it. They said, okay, let us have another shot. I'm like, okay, great. So I gave it back to them, and they did some more things. And they're like, all right, go find it now. We put some new stuff on there, and we deleted it. And so I said, oh, here it is, right here, right here, right here. And they were like, what are you talking about? Not only did we delete it, we reformatted the drive on the flash drive multiple times. So I said, oh, no, well, when something's been deleted, it doesn't necessarily mean it's been deleted, all right? And of course, we say that as sort of a mantra, and the kids are like, oh, yeah, whatever. But until they actually experience it, then you see this overwhelming, severely satisfying wave of shock and fear that comes into their faces. Like, what? You can still find it? And it's like, oh, yeah. So we talked about that for a bit. And then finally what they did is one kid said, give me overnight, I'll make sure you can't get it. So it's funny, he comes back and the thing was like almost destroyed and flat. And I said, what'd you do? And he goes, I ran over it with my car. So I was thinking, oh, this is horrible. You don't get the laughing when you do the virtual conference. I'm gonna have to put that down my list. But anyway, so it was flattened and it was like kind of destroyed because he said he ran over it with his car, and he goes, won't get the information now. But interestingly enough, what I did is, besides yelling at him, because it was my personal flash drive that I paid my money for. When I looked into the flash drive, there was an itty bitty little SD card in the inside of the flash drive. And I said, well, here you go. I said, now, although I don't have the material to read the itty bitty little SD card inside the flash drive, if I did, I'd still be able to get the information, right? So that was all, you know, that kind of came home for my students. They were like, oh, we need to know more about the software. Oh my gosh. So, and there's also a story about a burn barrel that if we have time at the end, I'll talk about the burn barrel story because that's a pretty hilarious story. So, interestingly enough, the thing about Autopsy that I thought was fascinating, now you all don't have the slide because I updated it recently and I couldn't figure out how to share it in the newer system, but that's fine. In a nutshell, if you're going to take anything away from this presentation, Autopsy covers every single subject that our students in cybersecurity and computer science education struggle with, because there is no direct, authentic, real world types of usage that students understand. So pretty much if you throw any subject that your students are missing the most, okay, like for example, system development lifecycle, right? They miss that one a lot because they don't get it, and they don't care, and they don't understand why it's important. There is actually the process for doing a system development lifecycle is very similar to the process they do in a computer forensic investigation. And when you think about it, it totally makes sense. Of course, you're not going to say, okay, well, we grabbed this guy's laptop and we ran it, and so we have all the evidence to put them away. So obviously, you're not going to win in a court case by coming out and saying that. You have to have a process. For example, how do I know you didn't manipulate the data before you copied it? You know, how do I know that you know, you don't have a report, you just said there was incriminating evidence. I need it documented where it was going to be. I need to make sure that you checked with someone else to make sure it was legal, doing all these things. So it follows a system development life cycle that's very similar to what we learn. We have to learn in some of our classes, especially career tech and IT. Another one is hexadecimals. Hexadecimals are very confusing for students. And they're like, why do we have to know hexadecimals? Well, obviously, we're going to get into something called hashing. And with hashing, it's a hexadecimal environment. So why do you think certain letters of the alphabet are not included in these hashes? Because they use a hexadecimal type of thing. So pretty much any subject you throw at it that I can think of, Autopsy covers it in a nutshell. It does a really great job in a real world type of fashion. All right, so before I go on, I notice there's lots of comments. I'm not looking at the comments. JR or Victoria, do you see anything in the comments that we have to address before we move on?
Not right now. Chrissy's actually doing a really good job as well, answering the questions before us, just really quick. So I think we're good.
Awesome, awesome, awesome. All right, so jumping in. Okay, so yeah, our students are, everyone's scared of it, but it's kind of awesome too, in a way. It's real powerful, free, available stuff. All right, so this is talking about why the cyber, now they didn't give me any money for this or anything like that, but I'm saying that Cyber Range is awesome. They solved a problem for me. The Autopsy program itself, which if you pull up the virtual machine, it's this little forensic, the cyber dog in the upper left-hand corner, is a very large file, an extremely large, several gigs, right? And then the E01, and we'll explain what the E01 files are. E01s are basically copies of complete computer systems, like a laptop. You have an E01 file from it. SD card. Those are extremely large files as well. Those are several gigs. They're so big, and then when it runs an analysis of things, it takes up so much memory on your computer. My little laptop, I had an extra laptop right here. This is actually the actual one. When I ran it on the extra little laptop, it basically blew it up. It blew it up. because the files were so huge that I said, this is not going to work. This is not going to work if I do it on our regular desktop systems, right? So I went to the cyber range and I said, is there any way we could run, you know, how much memory are we talking about here? I was like, I'm talking about potentially over 10 gigs in some cases of space. And they said, oh, sure. So they kind of put one together for me. That's why it's called Tweaks. Thomas Weeks did an awesome job putting one together for me, where we put the autopsy in there and we went ahead and run it in a virtual machine, and which is perfect, absolutely perfect. Now, this happened before I was told that my entire school system is going to go to one-on-one Chromebooks. And Chromebooks are fantastic because you can use virtual machines in Chromebook. There's even some programming environments and AutoCAD that we can't do on Chromebooks anymore. So potentially we could use these virtual machines in order to do that. So hats off to CyberRange. So that's what we're looking at right now. Okay, so what is an E01 file? Now, all these questions were not covered in the training that I did for autopsy. These are ones I looked on my own because I didn't know what they were. I noticed that they had one that was called a laptop, and they had something called MD5, which is sort of a hashing organization type of scheme put with these different devices. So an E01 file is basically a disk image backup of a complete piece of hardware. Like, well, why don't you just do it on the actual one? Why don't you just hook up your phone? Why don't you just hook up your flash drive like I did with our flash drive? I said in most cases you can, but when you think about it, it makes sense. In a digital computer forensic or a police investigation of a piece of hardware, you don't want to go directly to the source. You want to make a copy and then get the information that you need, because then again, you could be accused of manipulating the data from the other source. And if there's manipulation of data, of course, it'll be thrown out in court, right? So this lab that we're using is, we're mainly looking at the laptop. And then if we have time, we'll take a look at a media card file. So again, these are 2 copies of complete hardware systems, okay? Alrighty. So we're gonna jump right into it. This is not a workshop. This is just a presentation, but I did wanna make it so you had an opportunity to see what was there. We made a case for you. So I made a case on autopsy before I share it with you. So we went through several renditions. So if you have a chance, if you see the little autopsy 4.15.0 in the upper left-hand corner, go ahead and double click it. Again, if you don't have access to this module because you're using a phone, that's okay. It's, you know, if you do have access to a Google system later on in the future, I think this one is going to be up until the 29th. I think I have to replace the password after that. And then if you email me, I can make the new password available to you. All right.
Tamara has a question. Tamara has a quick question. She was asking which environment has the autopsy loaded.
It's in a Windows 10 environment. Oh wait, is that what she's asking?
Yeah, which environment has it loaded on?
Windows 10 environment. There is a CyberRange autopsy available through the Kali Linux, but then again, they actually customized this for me. So, which was the cool thing. The cool thing is that, again, if you're super stuck, they're very understanding of the CyberRange. You know, I haven't had any problems because they were just like, why don't you use this system? And I said, well, they say at the department, the Virginia State Police, they use the Windows system. You know, I know it takes up a lot of memory. It kind of blew up my laptop. I don't know if there's any way you could make it so it's a Windows system. And they said, sure. So you'll notice that you'll see the autopsy dog. Now, one thing I have to preface, again, because this is a law enforcement machine and it's a device, or not device, law enforcement app and not an educational app, it's not very user friendly. In fact, you can really just run one module at a time. They have these things called ingest modules. You can only run one at a time, really. or something crazy will happen. I'll explain what happens when it's later on. But what I did is I ran a few modules ahead of time because, again, it takes a long time, and I'll tell you why in a little bit. So if you open up, you're going to open up open recent case. If you open recent case, you should see open recent case. Again, it's not friendly. So you're like, I'm double clicking for all it's worth. It's not happening. It's happening. It just takes a while to do it. Again, it's not it's law enforcement, right? So typically what happens is I say, well, I asked my friend in digital forensic, I'm like, what do you do when it takes so long? And he was like, you go get coffee. So normally we would say open recent case, and eventually it should lead you to this. I created one for you ahead of time called Virginia Cyber Range. And if you say open, again, it'll take a while. Looking up the index, image gallery, you'll get an error message in the lower right-hand corner. You can just ignore that because the error message has something to do with the fact that you're not using a real, you're using a virtual computer, which is another reason why Cyber Range is so great. You're not, you're basically not using something that's going to communicate both ways and tell the main database, or which is known as a central repository, hey, I'm running a forensic investigation. I'm only 13 years old. You know, so the good news is that as it's encased in a little virtual machine, it's not really communicating both ways, which is always really, really good, which is why I'm really happy that, again, the Cyber Range is available. So you see you have lots of options here. So the device that you're looking at is the laptop. So let me go back to my slides. Back to my slides. Here we go. And let's take a look at a little bit of what we have. I've uploaded the laptop E01 data source. So we've basically said add data source, make it the laptop. And we went through the steps in order to make it you know, have it run a brief analysis on the fundamentals of this particular drive. So these are the steps you would follow if you were going to run it on the media card. Again, if we have time, we'll go through the process of running the media card, which will go a lot quicker than laptop. Laptop was huge, media card's not so big. Ingest modules. Okay, so when you go through and run ingest modules, your choices are amazing. So I know some of you, as well as myself, went through that session with the cyber.org people, where you had to run all these different little scripts and all these different little separate apps on a command string. The cool thing for Autopsy is, again, Windows environment, everything's readily available for you. Bad news, you got to run one at a time. You can't do what I call full cowling and run a whole bunch of modules at the same time. It'll basically explode. Well, it'll kind of explode in a way, corrupt all data, you can't see anything, nothing works. So we're going to talk about what each of these modules mean. And again, computer science tidbits in every single little module. First module. When I ran an analysis of the last laptop, I made it so it does what's known as a hash lookup. Basically, hashing is basically taking a string of characters, which is usually variable lengths of memory, right? You got big files, you got little files. It organizes them. Normally, a laptop or a computer or any device has their own hash sets, but it's all like random, basically random all over the place. As it gets created, it gets its own little hash set, right? The purpose of running a hash set using Autopsy is you are organizing, you are sorting it, so it is quick to search, Now, could you run all these little modules without running a hash set? Yes. The bad news, it will take forever, absolutely forever. So for some of my virtual teachers, maybe don't run a hash set. You know, if you want the kids to take a lot of time being engaged in the modules without it going quickly, why don't you do that? You know, that's an option. You know, I've timed it without doing a hash set. Doing a simple search takes, I would say, 16 to 20 minutes. So pacing wise, that's not bad, right? Oh my gosh, this is being recorded, isn't it? All right, so basically, hash sets take a long time. Now, the reason why you run a hash set, again, is you want searches to go quicker. But running the hash set itself, where it's organizing all the information, takes a long time. How long does it take? For example, I did little screen captures of all the times it took to get through the hash set. So we started at lunchtime, and we actually had to stop at 4:30 in the afternoon. It's Tom, I don't know if you're on here, but yeah, it was your fault. He just jumped into the virtual machine to see what I was doing and knocked me out, and I had to rerun the hash set. I'm like, no. Anyway, it took
My
about
bad. Sorry, Lean.
I thought you were here, Tom. No, that was awesome. That was hilarious, because then also we lost power. We had a major thunderstorm and we lost power. And I was like, oh, should I just give up on this? I don't know. But that was awesome. So we ran a hash set for you using something called the NSRL. Now, NSRL stands for, do I have where NSRL comes in? I'll say what that stands for in a little bit. That's a central repository of information that flags down things that are interesting, you know, in terms of investigation wise. Hey, you know, what do we got? So when we talk about hash sets, we need to talk about a file's digital footprint. Now, obviously, people have seen this information before. You have images, and then you have what's known as metadata on an image or an audio file or any multimedia file. In terms of, you have what's known as, you know, where did the file come from? Where was the information taken? You know, how many pixels is it? What location was it done? That's the reason why, I don't know if you've been using the Renovia app. I had a bunch of pictures of my dog on there, and then someone got on there and said, hey, maybe we can track the metadata from where the pictures were taken. And I was thinking, oh, so I started mass deleting pictures off the app. So that's where all my corgis went. Is he on here? No, I don't want to talk to him if he's on here. But anyway, that wasn't nice. There's things you can do to make sure your metadata is not revealed when you use pictures, but yeah, give us a heads up next time that happens. All right, so basically the metadata is giving you information. The metadata is being extracted, and the metadata is not the normal information. Like, we think the information, what tells us what kind of file it is known by file extension. No. Not necessarily. You could actually change the file extension, and devices like Autopsy and some other tools that are available through a Linux environment will tell you, like, no, this is an image file. They just changed the file extension at the end. And Autopsy does a great job of that. So we're going to get into something called pointers. Okay, so what pointers are, like, when we tell people, like, when you delete a file, it's never really gone, right? And so our students roll their eyes and they're like, yeah, whatever. And it's not until you freak them out with using things like flash drives and stuff like that and recovering their information, they're really freaked out. They're like, why is it still there? And it's like, well, when you delete a file, in most cases, you are not deleting the file itself. You are deleting what's known as the pointer. So the pointer is basically a memory address or a unique identifier that indicates where the file is located in with a memory address, which is a location on your hard drive, your RAM, or whatever, right? So basically the information is always still there. And so it's when you give them an example of something like this, and they freak out, then it's like, yeah, so, and then you let them dwell on it. I would recommend doing this activity like right before they're gone for the weekend, so they're just all freaked out and deleting everything from everywhere, right? So they just lose the pointer. There's fun story that I have, a personal story of police and the fire department doing donuts on my front school lawn, and it was my fault. Now, if we have time at the end of the session, I will talk about that story. But personally, I hope we were, but it has to do with pointers. It has to do with, and it's a good story. It's actually more interesting than the burn barrel story. But again, we can talk about that. It was all because of pointers. Pointers led us all wrong about that one. All right, so moving on. File extensions. Okay, so people were like, hey, the only way to identify a file, and this is what we do when we teach people things about computers at the early elementary stages. A file is identified by the 3-letter extension at the end of the file, right? And then you have JPGs, EXEs, DOCs, and that's not necessarily true. The way a computer keeps track of the file is basically by their hash set. And even if you change the name of the file, it will still say that's an image file. Now, will the app pull up the image file if you change the 3-letter designation? In most cases, no. Most cases, no. But in Autopsy, not only does it pull it up, you can take a look at it if you really want to. So it also identifies what's known as MIME, which is multi-purpose internet mail extensions, which basically gives indications and documentation on all the little things that go into things on the web, as well as emails, all right? And you also have access to things known as deleted files because you ran a hash set, and then which ones were flagged because you ran a hash set. So let's take a look at what we have here as a result of that. Let's go back to our Autopsy. Let's see, minimize that. Go to our Autopsy. All right, so you have a variety of views. You have file types, deleted files, as well as file sizes. All right. With file types, you have by extension. You also have documents, executables. Sometimes when a file is deleted, you have what's known as an orphan file, and those are the files where you have a $sign in the front and the back or some other symbol to indicate, hey, this file used to be, we're not sure where this file is in location anymore, but it's still, we're still storing it. It just doesn't have a set location. In most cases, they'll tell you where the file was located originally. So if you have a chance, let's do this until about 4:22. Feel free to go through these different images and documents and executables and deleted files. Some recommendations when you go through things like images. And there's a lot of images on here. In some cases, you should be able to pull up the file using, let's see, that's just giving you the metadata on the file. In some cases, you should be able to pull up the file using a viewer. In addition to the viewer, there's actually something called images and videos. In the upper left-hand corner, images and videos, I have a slide about that. We might as well bring this one out now, where there's an image gallery that gives you all the files from an image gallery. I would recommend from the image gallery, it's going to go through a lot of files in this image gallery, pulling out every single one, which should sort of freeze up your virtual machine. I would recommend also hash hits, taking a look at hash hits, and we'll talk about those in a little bit. Let's do that until about like 4:22. So it's 4:22 and we're back. So we've seen some of the files that are in there. Again, there's a lot of information on here. I'm a regular computer science teacher. There's probably some fantastic expertise as observers of this session. But I do flag what I think is very interesting and educational for my students. So in addition to showing the file type extension, we also need to talk about file extension mismatch. Okay, so now not only are we looking at what file extension files are out there, we are now starting to get into information where stuff had been manipulated on the files. Now, what's the main reason for manipulation? You want to cover it up, right? So I know that if we've ever caught our students like sort of overly sharing information, a popular way is to change the file extension. So this one is actually, it has what's known as an extension mismatch module. Now, this one basically pulls out files where it should have one type of file extension, but again, because of the metadata of the file and the hash, it's really a different type of file. And it's very interesting because you can get into conversations and education about how it's figuring that out. It even covers, it focuses on media and executables, which is great because if you just run an extension mismatch on everything, you're going to get a whole bunch of cache files. And cache files, again, is those sort of files where to speed up the process of running certain applications, if you've done the same types of applications, it runs quicker if there's some memory stored in the cache. So it actually just picks out the specific types of files that would interest someone like in law enforcement, documents as well as media files. So it'll run whenever extensions have been changed, right? Not only that, it also runs, now I don't know of the correct pronunciation, but is EXIF, is that the correct pronunciation of EXIF? Come on, JR.
I'm trying to Google super fast for you.
Okay. I didn't look up I'm calling it EXIF because that sounds cool, right?
I'm not sure,
Yeah,
to be honest.
yeah, it's EXIF.
Okay, thank you so much. So it stands for Exchangeable Image File Format. Basically, it indicates that it is an image file and it can be identifiable using its hash data. All right, so without going too deep into the woods, basically, if you've ever done a reverse image search, and actually I found out about reverse image searching from the show on MTV called Catfish. So if you get these image files and you're like, I don't know if this person is real, I'm really not sure if the celebrity is really talking to me. So you run a reverse image search just to make sure that's the same name. Like, oh, that supermodel's talking to me. And then you run a reverse image search and you find out through Google that the image is not working. Well, how do you do that? Basically, it shows based on its metadata about the image. It can basically do a reverse image search or give you information about the file that it's like, hey, well, this is an interesting file. We've seen this file before and it's located somewhere else. And it talks a little bit about where the file has been used and where it appears and why you should look at it. For example, things like there might be a cover page to the dark web or something like that, right? So that's a really interesting area when you talk about, how does it do these types of searches, especially on image files. And then have people do a reverse image search is always really interesting because they're like, oh, I didn't know it works that way. And it's like, yeah, Google searches everything. So anyway, so that's an EXIF module. Encryption detection module. Okay, this is one of my favorite ones. It flags files and volumes which are encrypted. Okay, just like EXIF. I know, man, just like file extension mismatch. Why do you think things are encrypted? Well, things are probably encrypted because people want to make sure other people can't see the files, right? So not only does it indicate which files are encrypted, it actually allows you to go in there and see what's in the encrypted files. Now, a quick warning, this file, again, it's a law enforcement tool. Now, we can get into discussions later on if we have time about should we let our students loose on this technology? And I said, well, I mean, here's the thing. Are they really hacking? Are they manipulating data? They're seeing what's already there. But for some people, that's a double-edged sword, right? I don't recommend you go into running this encryption detection module with your students. And the reason why is because if they use it on like a school computer, it can extract everything, including passwords for things that they really have no business getting into. So, you know, it's your choice. It's your choice, but we could get into discussions about encryption and how it works and how it's basically figuring out how to get a hold of the files anyway. It actually goes into the encryption and kind of pulls out the metadata of the file, and then it just kind of recreates it from there. It's scary stuff, but it's awesome stuff. So that's the encryption detection module. I've even included a cute little video from the people at code.org talking about different types of encryption and how they work. So this is a really good one for an example of talking about security and encryption. Recent activity and timeline interface modules. Well, you know, it makes sense from a law enforcement perspective. Obviously, you don't have time to look at every single file that was pulled up on a particular device when it's been confiscated. Sometimes you want to look at a particular window of time, right? You want to look at a particular window of activity. That's a known as a Boolean logic type of search. But you don't see that. That's happening in the backgrounds. But basically, it makes total sense. You know, why do we need to do this and or not type of business? It's because if you need specific pieces of information, because data is ridiculously large, you can look in a particular window of time. You know, hey, this crime was committed between this time and this time. Let's go back, you know, that evening and 2 days before and 2 days after, and, you know, so recent activity timeline is a great discussion of using Boolean operators, right? Okay. Keyword searches. Okay, keyword searches are fantastic because normally it will take forever if you don't run a hash set. So the hash database basically sorts the data so it can provide a search quickly. And then you can do keyword searches by exact match, substring match, or regular expression. You can have it ignore capitals and lowercase letters. It does a really good job at doing that. Here's a video. I would say only watch the first half of this video because then it gets into the code.org type of coding. You don't need that. But this is a really good, keyword searches are really, really, really strong. We're actually going to perform a keyword search if we have time at the end. All right.
Yeah, so it's past 4:30, but if anyone has any time constraints, you could leave your questions in the Whova Q&A and they'll be answered. But if you want to continue, Eileen, you can keep going if you want. If anyone